how can we graph the line y equals x? Y and x are letters, and in math, letters are called variables, which are just letters that represent numbers. So for example, the letter x can be 1, 2, 3, or any number that we want it to be. The letter y is also a variable and can also be any number. To start, it's wise to start off with the table. Let's find what y is when x is 0. So what we're going to do is we're going to use the equation. We're going to replace the letter x, the variable x, with the number 0. So it turns out when x is 0, y equals 0. Now what about when x equals 1? What we're going to do is we're going to take the letter x and we're going to replace it with 1. So y equals 1 when x equals 1. Now what about when x equals 2? This time, instead of erasing x and replacing it with the number, I'm going to write a new line. When you're doing homework, quizzes, or tests, you never want to erase a variable because it takes too much time. Instead, what you want to do is write a new line where you copy the first line, except you change the one thing that you want to change. So in this case, instead of writing x, we're going to change it to a 2. So it turns out that y equals 2 when x equals 2. Now what about when x equals 3? So instead of erasing anything, we're just going to copy the first line, and we're going to change the one thing that we want to change. So we're going to want to change x to 3. It turns out that y equals 3 when x equals 3. Now that we have a few points, we can start graphing. This is called the coordinate plane. And the horizontal line here is called the x-axis, which is why there's an x at the end of it. Now the vertical line is called a y-axis, which is why there's a y at the end of it. The numbers on the x-axis are related to the numbers here, while the numbers on the y-axis are related to the numbers here. Recall how points work. It's written as x, comma, y. So these values are the same thing as points, except they're written in another form. So this point here can be written as 0, 0. This point here can be written as 1, 1. This point here can be written as 2, 2. And this point here can be written as 3, 3. So the table is pretty much the same thing as having multiple points, except they're just written in a different way. Now let's try to find where these points are. When x is 0, y equals 0. So on the x-axis, x is 0 is right about here, and y is 0 is about here. They're not labeled, but they're always at this corner. So the point's going to be right about here. When x is 1, y equals 1. X equals 1 is here, and y equals 1 is here. And they meet about right here at this corner. So the point's going to be right here. when x is 2, y is 2. So x is 2 is here, and y is 2 is here. And they meet right about here. So this is where our point's going to be. When x is 3, y equals 3. And these meet right about here at this corner. So this is where the point 3, 3 is. And now what we're going to do is we're going to connect these points in a straight line. Now at the end of the line, we have to draw an arrow. And this is because the line can go on forever. So for example, if I wanted to find where y is when x is 5, I can. Or if I wanted to find what y is when x is 100, I can. Or if we wanted to go to x is 1000, we also can. So notice how the line can technically go on forever. We can find points forever. Now let's take a look at the table. How is y changing? Is there a pattern? Notice how it goes from 0 to 1, and then 1 to 2, and then 2 to 3. It's increasing by 1 each time, because 0 plus 1 is 1, and then 1 plus another 1, that's going to be 2, and then 2 plus another 1, that's going to become 3. But it's constantly increasing by the number 1. This number is called the slope. And in math, we like to write the slope as the letter m. So the letter m just means the slope. And in this case, the slope equals 1 because it's increasing by 1. Now let's pretend you didn't know what the equation is. The equation is y equals x, but let's pretend that we don't know that. And let's pretend that we're only given 2 points. So let's pretend the only points that we have are 1, 1 and 3, 3. How can we find the slope? Only using these 2 points while also not knowing what the equation is. Well, it turns out there's a formula for the slope, which is m equals y2 minus y1 over x2 minus x1. The numbers 2 and 1 below the variables are called subscripts. Now these numbers are used to differentiate which point is which. So for example, if 1, 1 is the first point, and 3, 3 is the second point, three is going to be x of 2. The 2 means that it's the second point. And the 3 here is going to be y of 2 because the 2 represents the second point. For this, 1 is going to be x of 1 because the 1 means that it's the first point, and then y is going to be y of 1 because the y means that it's the first point. It's the y value of the first point. Now the points we have are 1, 1 and 3, 3. And it doesn't matter which point we decide should be the first point or the second one. So for instance, if we want to make 1, 1 the second point, 3, 3 has to be the first point. Or if we want to make 1, 1 the first point, then 3, 3 has to be the second point. But it doesn't matter which one we pick. In this case, let's make 3, 3 the second point, while 1, 1 is the first point. So what we're going to do is we're going to use these values and we're going to plug them into the formula. So in the second point, we're going to have x of 2 and y of 2. Notice that y of 2 is going to be 3. Now we have to subtract y of 1. In the first point, we have x of 1 and y of 1. So y of 1 is going to be 1. Now we got it divided by x of 2, which is 3, minus x of 1, which is 1. So what we have is 3 minus 1 over 3 minus 1, and that's going to be 2 over 2. And 2 over 2 is the same thing as 1. And this confirms our answer. The slope m equals 1. So this is how you find the slope if you're only given 2 points and you don't know the equation. Now let's graph the equation y equals 2x. Let's start with the table. Now what's y when x is 0? So what we're going to do is we're going to replace x with 0. So we have 2 times 0, and anything times 0 is 0. So that means y equals 0. Now what about when x is 1? So we're going to copy the first line, and the only thing that we're going to change is x. So we're going to change x with the number here, which is 1. 2 times 1 is 2. So that means y equals 2. What about when x is 2? So what we're going to do is we're going to replace x with 2. So we have 2 times 2, and that's going to be 4. So y equals 4. Now what about when x is 3? So let's take the first line. Now we're going to replace x with 3. 2 times 3 is 6. So y equals 6. So y is 6 when x is 3. So before we go any further, let's find the slope of the equation using the table. So recall that the slope, m, is how y is changing. So from 0 to 2, it's increasing by 2, because 0 plus 2 is 2. From 2 to 4, it's also increasing by 2, because 2 plus 2 is 4. From 4 to 6, it's also increasing by 2, because 4 plus 2 is 6. So m equals 2. Notice how the number to the left of x is also 2. It turns out the number to the left of x is directly correlated with the slope. Now let's take a look at the old equation. Y equals x. We know the slope for this equation is 1, but it doesn't look like there's a 1 before the x. However, what we can do is we can pretend there's a 1 there, because 1 times anything is just that number itself. It doesn't change anything. So that's why we can pretend that there's a 1 there, and we can say that the slope is 1. So an easier way to find the slope is just look at the number to the left of x, and that number is going to be your slope. And by the way, the number to the left of x, or any variable, is called the coefficient. So 2 is the coefficient of x, which basically means that it's just the number to the left of x. And now let's graph the line. So let's use the points. When x is 0, that's right here, y is also 0. So the point's going to be right about here. When x is 1, y is 2. So that's going to be right about here. When x is 2, y is 4. And they happen to meet right about here, in this corner. When x is 3, y equals 6. These happen to meet right about here. And now we can connect the dots. And recall that we have to draw an arrow at the end to indicate that it can go on forever. So this is the graph of y equals 2x. Now let's compare this to the graph of y equals x. How are they different? Well, it seems like y equals 2x, the white line, is a lot steeper than y equals x, which is the golden line. So this means when the slope is larger, the line's going to be steeper. Now let's double check to see if the slope is actually 2, just in case we made a mistake. Recall the formula m equals y2 minus y1 over x2 minus x1. Recall that the subscripts, the small numbers below x and y, are just ways to indicate different points. So x1, y1 is 1 point, and x2, y2 is another point. So let's pick 2 random points. It doesn't matter which points we pick. So let's pick 1, 2 and 3, 6. And let's have 3, 6 be the second point. So that means 3 is going to be x of 2, and 6 is going to be y of 2. So let's plug this into the formula. Y of 2 is 6. And since 3, 6 is the second point, it means 1, 2 is going to be the first point. And that means 1 is going to be x of 1, while 2 is going to be y of 1. So y of 1 is 2. X of 2 is 3. And x of 1 is 1. So now we have 6 minus 2, that's going to be 4, over 3 minus 1, that's going to be 2. And 4 over 2 simplifies to 2. And the slope is also 2, so we know we got the right answer. Another concept I want to introduce is how slope equals rise over run. So let's take a look at the graph. Let's use the graph as an example. And we're going to pick 2 random points. So let's pick 1, 2 and 3, 6. We don't necessarily have to pick 1, 2 and 3, 6, but I'm just going to pick it as an example. But remember that you're allowed to pick any 2 points. So run is how much we have to run to the right on the x-axis. So to get from x is 1 to x is 3, we have to run 2 units to the right. And rise can either be going up or down. So in math, rise doesn't necessarily mean it has to rise. It can go down as well. So to rise, we're going to go from y is 2 to y is 6. So we're going to rise 4 units. So this is how we can go from 1, 2 to 3, 6. We got to run 2 units to the right, and then we got to go up 4 units. So going up and going down, the vertical movement, that's correlated with rise. And the movement to the right, that's going to be correlated with run. So now that we have rise over run, we know that the rise is 4 and that the run is 2. And notice how we get 4 over 2, and this is 2, and that's our slope. And this is actually the core idea behind the slope formula. The slope formula is y2 minus y1 over x2 minus x1, where there are two random points that are x1 comma y1 and x2 comma y2. Now let's draw a small graph to understand what this means. So one of the points is at x1 and y1, and they meet right about here. So this is where that point is. And then we have x2 and y2, and these meet right about here. So that's where the next point's going to be. And now let's connect these 2 points. And let's take the rise over run idea. So we're going to run from x1 to x2. We're running to the right. And then we're going to rise from y1 to y2. How can we write this algebraically? Well, since we're going from y1 to y2, we want to find the distance between y2 and y1. And it turns out the distance is going to be y2 minus y1. For the run, the same thing applies. We want to find the distance between x1 and x2. So we're going to take x2, and then we're going to subtract x1. And this is going to be our distance. And now let's put this into the rise over run formula. Rise is y2 minus y1. And the run is x2 minus x1. So this is how the slope formula is derived. y2 minus y1 is the rise formula, and x2 minus x1 is the run formula, because it's finding the distance. So this is why the slope formula works for any 2 points. Now let's graph y equals 2x plus 1. How does the plus 1 change the graph? Well, it turns out the plus 1 doesn't affect the slope. So if we make a table, when x is 0, if we replace x with 0, 2 times 0 is going to be 0. But we still have a plus 1. And 0 plus 1 is going to be 1. So that means at x equals 0, y is going to equal 1. Now what about when x is 1? So let's take the first line, and we're going to copy everything except for x. We're going to change x to 1. 2 times 1 is 2, and we have a plus 1, so this is going to be 3. You can solve the rest of the points for practice, but to demonstrate, I'm just going to write them out. Notice how from 1 to 3, it's still increasing by 2 because 1 plus 2 equals 3. And then from 3 to 5, it's also increasing by 2. And from 5 to 7, it's also increasing by 2. So the slope stays the same. And now let's double check to make sure. Let's use the slope formula. Recall that the slope formula is y2 minus y1 over x2 minus x1. Let's have 0, 1 be the first point. And let's pick another random point, 2, 5, and let's make it the second point. So recall that 0, since it's the first point, is going to be x of 1. And the y1, which is also the first point, is going to be y of 1. And then for this, 2, 5, since 2 belongs to the second point, it's going to be x of 2. For y, since 5 also belongs to the second point, it's going to be y of 2. Notice how the subscripts, the small numbers below the variables, are directly related to whether if they're the first point or the second point. Now let's plug this into the formula. So y2 is from the second point, and that's going to be 5. y1 is from the first point, and that's going to be 1. x2 is from the second point, and that's going to be 2. And x1 is from the first point, and that's going to be 0. So let's make some space. Let's start over here. 5 minus 1 can simplify to 4. 2 minus 0 is still going to be 2. Now we have 4 over 2, and that's the same thing as 2. So we've confirmed that m equals 2. So that's the right answer. And now let's graph the equation. So at x equals 0, y equals 1. So the first point is going to be right about here. And at x equals 1, y equals 3. And they meet right about here. So the point's going to be right there. And at x equals 2, y equals 5. And that's going to be right about here. And at x equals 3, y equals 7. So that's going to be right here. And now let's connect the dots. It's a little bit off, but that's okay. And now we're going to draw an arrow to show that it goes on forever. And now let's find the slope with the rise over run concept. Recall that run is how much one point has to run to get to another point to the right. Recall that run is how much one point has to run to the right to get to the x value of another point. And rise is how much the point has to go up or down to get to the other point. So let's pick 2 random points. Let's do 1, 3, and then let's do 3, 7. So the points are right here. So we're going to run from 1 to 3. And then we're going to rise from 3 to 7. So we're going to go up 4. So we went up 4 units, and then we're going to run 2 units to the right. So the rise is 4, while the run is 2. 4 divided by 2 is 2. So this confirms our slope. Let's take a look at the original graph, y equals 2x, the graph that we drew before this. Y equals 2x is going to look something like this. The white line is y equals 2x plus 1, and the golden line is y equals 2x. So notice the only difference is that the plus 1 shifts the graph upwards. So that's what the plus 1 does. Now, why is slope so important? The reason slope is so important is because we can actually use it to help us graph faster. So let's take a look at y equals 2x plus 1 again. By looking at the coefficient of x, which is the number to the left of x, we can tell that the slope is 2. Now we only need 1 point. And I recommend using the point at when x is 0, because multiplying anything by 0 is really easy. So what we're going to do is we're going to replace x with 0. So notice how 2 times 0 is going to be 0, but then we have a plus 1. So we have 0 plus 1, and this is going to be 1. So y is 1 when x is 0. And this is pretty much the only point we need. So this point is right about here. And now we're going to use rise over run to help us graph. So let's think about rise over run really quickly. So remember, rise over run is how much the graph has to rise divided by how much it has to run to the right. We also know that m happens to equal 2. So rise over run equals 2. Now what we can do is rewrite 2 as 2 over 1. Because 2 divided by 1 is still 2. It's still the same number. So if we take a look at rise over run, notice how it's 2, so we have to rise 2 up, and then we have to run 1 to the right. So for every x we run to the right, we're going to go up 2. So let's use rise over run to help us graph this. So we're going to start at 0, 1 because that's our first point. And then we're going to run 1 unit to the right. And now we're going to go up. We're going to rise 2 units. So we're going to go from 1 to 3. So the new point is at 1, 3. And now let's use it again. So let's run 1 unit to the right. And then we're going to rise 2 units up. So we're going to go from 3 to 5. And the new point is going to be at 2, 5. And now we can repeat the process for one more point. We're going to run 1 unit to the right. And then we're going to rise 2 units up. We're going to go from x2 to x3. And then y5 to y7. So the next point is going to be at 3, 7. And now let's connect the dots. It's going to be a little bit off, but it's just a rough sketch. So this is the line y equals 2x, and we graphed it using rise over run. Now let's use this idea to graph another line. Let's graph y equals 3x. So I recommend you finding the point where x is 0, because 0 is really easy to use, because 0 times anything is just 0. Y equals 3, and we're going to replace x with 0. 3 times 0, that equals 0. So when x is 0, y equals 0. And now just by looking at the graph, we know that m, the slope, equals 3. We also know that m equals rise over run. And that's going to equal 3. Now recall that 3 can be rewritten as 3 over 1, because anything divided by 1 is still that number. So 3 divided by 1 is still going to be 3. So rise over run also equals 3 over 1. So rise over run equals 3. And 3 equals 3 over 1. So that means rise over run equals 3 over 1. So what we're going to do is for every x we run to the right, we're going to go up 3 units. So let's draw the graph. So again, this is just a rough sketch. So let's start at the first point, 0, 0. Now let's use rise over run. So we're going to run 1 to the right, and now we're going to go 3 up. So our new point is going to be at 1, 3. And now we're going to run 1 to the right, and we're going to rise up 3 units. So our new point is going to be at 2, 6. And now we're going to run another unit to the right, and we're going to rise up 3 more units, so we're at 3, 9. And now let's connect the dots. And remember to draw that arrow to show that it's going on forever. So this is the graph of y equals 3x. Now let's double check that the slope is correct. So let's pick 2 random points, and let's pick 1, 3, which is when x is 1 and y is 3. And then let's pick 3, 9, which is when x is 3 and y is 9. So again, let's use rise over run to check our answer. So from 1, 3, we got to go 2 units to the right to get to x equals 3. And now we're going to go up to 9. We're going to go from y equals 3 to y equals 9. So we're going to go up 6 units. So rise is 6, and run is 2, and 6 divided by 2 is 3. So that means m is correct. So we have the correct slope, and we graphed it correctly. Now you might have heard of y equals mx plus b. This is the standard form of the equation for a line. So m is the constant coefficient of x, and b is just a constant. And by the way, a constant is just a normal number that doesn't change. So for example, if we had the equation y equals 2x plus 1, 2 and 1 are going to stay 1 no matter what. The only variable we're changing is x. So 2 and 1 are constants because they're just normal numbers that don't ever change. So if we imagine we're using a table, we always change what x is to find y, but we never change 2 or 1. They always stay the same. So why is this so important? It turns out that m represents the slope, as I've mentioned earlier. So m, which is the coefficient of x, is the slope. B is going to be used to help us find the y-intercept. But what is the y-intercept? This isn't a strict definition because I haven't covered some important topics in this video. which I'll cover in the second part of this video. But for now, pretend that the definition of a y-intercept is this point. It's the point where the graph touches the y-axis. And at this point, notice how x is 0. So let's find out what y is when x is 0. So we're going to replace x with 0. Now recall that anything times 0 is just going to be 0. So m times 0, that's going to be 0. And then we have a plus b. 0 plus anything is just going to be that number itself. So 0 plus b is b. So that means when x is 0, y equals b. So the point's going to be 0, comma b. This is the y-intercept. So the y value right here is going to be b. What the y-intercept does for us is it gives us a free point without even plugging in any numbers to a table. We already know that one of the points is going to be 0, comma b. And combined with the slopes, we can draw graphs really quickly. So let's say we had to graph the line y equals 2x plus 2. We know that b is 2. So our y-intercept is going to be at 0, comma 2. And x is always going to be 0 at the y-intercept. Now if we really wanted to be safe and check, we can always use the equation. So let's replace x with 0. And 2 times 0 equals 0. And then we have plus 2. 0 plus 2 equals 2. So y equals 2 when x equals 0. So this point is correct. Now the slope is 2. So let's use the rise over run formula. So rise over run equals 2. And we can rewrite 2 as 2 over 1. It's going to be the same thing. So now we know that for every x value we run 1 to the right, we're going to rise 2 units up. So now let's start graphing. So we know that there's a point at 0, comma 2. And now we're going to use rise over run to take care of the rest. So we're going to run 1 unit to the right, and then we're going to rise up 2 units. So this is our second point. Our second point's going to be at 1, comma 4. And now from here, we're going to run another 1 unit, and then we're going to rise up another 2 units. So this is our second point. It's going to be at 2, comma 6. And then we're going to run 1 more unit to the right. And then we're going to go up another 2 units. We're going to go up to 8. So this is our third point. And now, let's connect the dots. It's not going to be perfect, but that's okay. And then we're going to draw an arrow to show that it's going on forever. So this is the graph of y equals 2x plus 2. And now let's graph some slightly weirder graphs, where the slope might be a little bit strange. Let's graph y equals 1 over 3 x. Now first let's find the y-intercept. Notice how we don't really have a plus b here. So what we can do is we can pretend b equals 0, because this way we can do plus 0 and everything stays the same. So we can pretend that b is 0, and that means we have a point at 0, comma 0. But let's check our work, just in case we mess something up. So let's replace x with 0. 1 over 3 times 0 is 0 because anything times 0 is 0. So this is going to be 0. So when x is 0, y is 0. So we're right. Now let's take a moment to think about the slope. The slope equals rise over run. So recall that for whole numbers, like 3, what we did was we changed it into a fraction. And we made it divide by 1, so that way it would remain the same thing, except in fraction form. So that way we knew that it went up by 3 units while running 1 unit to the right. So in this case, the slope is going to be 1 over 3. But notice how this is already in fraction form. So what we can do is just keep it this way. We don't have to change anything. So every time it runs 3 units, it's going to rise up 1 unit. And now let's graph this out to see how it's going to look. So let's start at the point 0, 0, because we know that that's a point that exists on the graph. And now we're going to use rise over run to graph the rest. So we're going to go to the right 3 units. We're going to go from 0 to 3. And then we're going to rise up 1 unit to y equals 1. So this is our second point. And now we're going to run another 3 units to the right. So we're going to go from 3 to 6. And now we're going to go up 1 unit. So we're going to go from 1 to 2. So we have a point here. Now we're going to do this one more time. We're going to go from 6 to 9 because we're going to the right 3 units. And then we're going to go up by 1 unit to 3. And now let's connect the dots. And now to top it off, we're going to draw an arrow to show that it goes on forever. So this is how you can draw more strange looking graphs. And now let's do one more thing. Let's check our work. Let's check if we really have the slope correct. So let's pick 2 random points. Let's do 9 and 3, and then let's take 3 and 1. Now let's see how we can get from 3, 1 to 9, 3. So first we got to go from x is 3 to x is 9. So it's going to run 6 units. And then to get from y is 1 to y is 3, it's going to go up 2 units. So the rise over run in this case is going to be 2 over 6. It's going to rise 2 units and it's going to run 6 units. And we can simplify this to 1 over 3. Since these match, we know we graphed it correctly. Now let's graph y equals 2 over 3x plus 2. So first let's find the y-intercept. So the y-intercept is going to be at when x is 0, and the y value is always going to be b. And in this case, b is 2. And now, let's find how we're going to handle the slope. M, which is the slope, equals rise over run. And the slope is 2 over 3. But notice how it's already a fraction, so we don't have to change anything. So we're going to run 3 units And every time we run 3 units, we're going to go up 2. So we're going to start at the first point, 0, 2. And now we're going to use rise over run. So we're going to run 3 units to the right. So we're running 1 to 3. And then we're going to go up 2 units. So we're going to go from y is 2 to y is 4. And now we're going to run another 3 to the right. We're going to go from 3 to 6. And then we're going to go up 2 more. And now we're going to run another 3 to the right. And we're going to go up to 8 because we're adding 2. So we're going up by 2. And now let's connect the dots. And let's run arrow to indicate that it goes on forever. So this is the graph of y equals 2 over 3x plus 2. So this video is the first part of a longer video, and the initiative with this video is to provide a strong foundational understanding of how graphing equations works. And I'll make a video in the future that covers more about graphing, so I'll explain how to graph with the 4 quadrants, negative numbers, negative slopes, and so on. So once that video is finished, I'll put it in the description of this video. Thanks for watching.